Hi, physics students. We are covering our last new material of the year today. So, before I move into electromagnetic waves, I thought I would cover just a couple quick things from Monday's assessment. So, there a lot of confusion about what depends on what. That's not unusual. That happens every year. So, what I want you to do is consult your notes, and if you need to add to your notes, put what depends on what, please do that so that you're not confused on test day next Tuesday. Um, so frequency and period are the cause. They are always a cause. They change at the source of the wave. And then wavelength is an effect. So if I change F in my formula, that's on the right side of the formula, okay? That is a cause, and then a change will occur in the wavelength, that's an effect. Then when we talk about wave speed, well, that's a little more complicated because we know that wave speed depends on the medium. Is the medium air? Is it water? Is it a slinky that's really tightly held, or is it a slinky that's kind of loosey-goosey? Okay, if the medium changes, that's the only thing that would change wave speed. Okay, if the medium changes the wave speed, then as a domino effect, then that will also change the wavelength. Okay, amplitude is just its own thing. So that changes at the source. You know, how much is that guy shaking the slinky up and down? In this wave pool picture, how much is the source of the wave pushing on the water? Okay, how hard is it pushing on the water? That's what's setting the height of the wave. How high do you go when you're in jumping the waves or you're sitting on the little floaty? Okay, that is amplitude. That has no effect whatsoever on how often the waves come. That's called frequency, right? But that has to do with how often that wave maker is vibrating back and forth. That the two things don't have anything to do with each other. They also don't have to do with wave speed. Like when you are waiting in the wave pool for the wave maker to start back up again, if you're in the shallow end, you have to wait a while for the wave to come to you. That doesn't have anything to do with frequency. It doesn't have anything to do with amplitude. It's just a function of the medium, the water you're in. How long is it going to take to get to you? That has nothing to do with the wave maker. Okay. So then the drip question, I did get a lot of questions on this one, and I just want you to remember that frequency and period are reciprocals of each other. That's why I tend to put them together a lot. They are not the same thing though. Okay, so frequency is cycles per second, otherwise, or waves per second, otherwise known as hertz. Seconds goes in the denominator. Period is how much time, how many seconds does it take for a single cycle or a single wave? So that is in seconds. It needs to have seconds in the numerator. Okay? All right. Then let me pause and switch presentations so we can go over today's note. Okay, today the type of wave we're talking about is called electromagnetic. It's great that we've already taught electric fields and magnetic fields because this type of wave is just a combination of those two. So you can see in this picture, we've got E standing for electric field, B standing for magnetic field. These types of waves are transverse waves. They do not require a medium, so they can travel through the vacuum of space. They have to, right, to get from our sun to our planet Earth. Because, for instance, one type of electromagnetic wave is sunlight. So here's the chart that shows all the types of waves that are included in this category. And humans have broken this up and named different parts of this spectrum, okay, for our convenience. And you can see if you, it's better in the notes that I put online, but, or in your book. it shows how the frequency goes up as you go from what we call the radio spectrum to all the way up to the gamma rays, okay? So as the frequency goes up, because frequency has an inverse relationship with wavelength, then the wavelength is getting smaller and smaller, shorter and shorter, okay? So it's a little confusing because they're showing frequencies going up in this direction, wavelength is going up in the other direction, okay? It's also showing detectable objects here, okay? That's because as the waves are getting smaller and smaller in wavelength as you go down this table, then you can, they will interact with smaller and smaller objects, and then you can use them as detectors, okay? So when we're looking, for instance, X-rays are important. They're not just in X-ray machines, but they're also in CAT scanners, okay? So if you go in for a scan, then you're using that technology to look at molecules in the body. So that's pretty useful, but it also can be harmful. So today's activity is going to be asking you actually, are cell phones harmful to the body? Or cell phone towers if you're living and working near a cell phone tower. So it'll be interesting to see because the articles we're posting are kind of mixed results, right? So, and then some other characteristics that they have in common. All these waves have the same wave speed as each other. The speed of light, I mean, they're naming it after light, but it goes for all of these. So it has a certain number that's famous that is C in the E equals mc squared formula, which is this one. But that's the number for light traveling through the vacuum of space. So it would be slower when it's traveling through solids, liquids, and even a tiny bit slower in gases. Okay, and then obviously light is important to us because that's how we perceive a lot of the world around us with our eyeballs. So different wavelengths of light are what our brain perceives to be different colors, which I think you learned in middle school. And then the amplitude of a light wave, our eye and brain perceive as intensity. Okay, and then I thought this was a curious question that maybe you've thought about before, because air does not have a color, right, on its own. So then why do we, when we look up at the sky, why do we see it as that blue color that it is? So if you look at this diagram, it's trying to explain that the gas molecules that are present in our atmosphere are scattering blue light and letting the other wavelengths of light through. And because our brain is telling us that, oh, that color is what we see as the color that's reflected by objects, then we're seeing the blue because that's what the nitrogen gas and the other gases in our atmosphere are letting bounce around from our sun's wavelengths. Okay, and then I thought we'd also talk about, since we're going to be talking about cell phone topics today, we'd also just cover a little bit about the microwave and radio part of the spectrum. There's so much we could cover, but we don't have time for it all. So I thought I'd mention that microwaves and radio waves are naturally occurring. So our sun emits those waves, and the whole universe, the other solar systems emit those waves. So we are measuring those with satellites and radio telescopes. You can see here the famous radio telescope in Puerto Rico. But also humans have made good use of radio waves for communication. So when we are doing that, what's happening is that the for instance, one example is a radio station that is transmitting from a tower, and they are sending out a signal at a certain frequency. You can see, the frequencies here. They're never giving you the units. Those are in megahertz. And so then when you are in your car, if you still use your tuner, if you're not using satellite radio, then you're using a tuner to tune in the frequency and choose out of all the frequency radio waves that are bouncing around all the time through the air, you are picking one. And that particular one is resonating when you turn the tuner to a particular number. So that's the receiver end. Okay, and then that radio station is always broadcasting, but you are just choosing to tune in to that particular one. But the radio spectrum, the government is splitting that up. So they're in charge of defining what parts of the radio spectrum are we going to use for different purposes. So they've chosen and specified so that everybody agrees, okay, here's what we're going to use different parts of that spectrum for. So we're using it for navigation, we're using it for TV. So even though it says radio, it's also used for TV. It's used for Wi-Fi, and then for cell coverage and lots of things I'm not talking about here. So talking about cell phone coverage, they've expanded this over the years, and you can see that here. What's 6G? Is that a thing? This seems a little optimistic, but okay. So the cell spectrum goes in at the high end of radio and into the low end of what we would call the microwave section of the spectrum. And it's just showing how that's changed over the years in what it's using, which part of the spectrum. Okay, and then the last thing that I wanted to talk about, as long as we're talking about microwaves, how come, we're getting microwaves coming in from our sun, but we're not cooking. It's not cooking me. I will get cooked by infrared if I don't put sunscreen on. But what's happening inside your oven is a lot of reflection of microwaves on purpose. And so the microwaves are bouncing around on the inside in a way that cooks the food. And what they're doing is transferring energy to water molecules, because those are polar molecules that respond to that electromagnetic field, right? Because they feel attracted, repelled by those electric fields. And so that makes those water molecules vibrate. And when things shake, they get warm. So you're transforming that electromagnetic energy into thermal. Pretty cool. Okay, or I should say pretty warm. Yeah, you're welcome for that joke. All right, so today you're going to be reading some articles following what your teachers have taught you about. Is this a good source? What scientifically is this a valid source? How many people were included in this study? So you don't have to read all the articles, okay? So I'll include some directions, and we're going to hopefully have a good discussion about what arguments are valid and what we should be thinking about cell phone use and or living near a cell phone tower. Okay, thanks, ladies.